Special theory of relativity. In 1905, Albert Einstein proposed a theory that completely changed our view of space and time. He based his special theory of relativity on two postulates: the particle, the principle of relativity, the law of physics that the same in all internal reference frame. The first postulate declares that the law of physics are absolutes, universal, and the same for all internal observers. Law and that hold for one internal observer cannot be violated for any internal observer. Einstein's principle of relativity means that any kind of experiment, mechanical, thermal, optical, and electrical, performed in a laboratory at rest must give the same results when performed in a laboratory moving in a constant speed past the one time. For example, the pouring of tea is an aeroplane moving with constant speed is same as the earth. The principle of constant of speed of light. The speed of light in the vacuum has same value. C is equal to 2.9979248 multiplied 10.8 meter per second. In all internal reference frame, regardless to the velocity of the observers or the velocity of the source emitting the light. The second postulate is more difficult to accept. It seems to go against our common sense, which we observe, which we observe in everyday experience. Consider, consider two experiments since a torch A and the other torch B, as shown in the figure is above. But these experiments regardless only if at the rest of move with respect to each other fine in every situation, light traveling from the same speed as c is equal to 3 multiplied 10 power 8 meters per second. Consequences of special theory of relativity. As we examine some of sequences of relativity, we will find that they contradict some basic concepts. Non-internal reference frame. An accelerating frame of the reference is called non-internal frame of reference. Any reference or system move with constant velocity with respect to an internal system must also be an internal. Thus, there is no signal prepared internal frame is shown in the figure 18.2. The Earth-based reference frame is not exactly in the internal reference frame because it is subjected to centripetal accelerations as the Earth's spin on the axis that revolves around the Sun. In most situations, the effect of these accelerations are small and we can neglect them. Therefore, the Earth's surface can be considered as internal reference frame at any situation. For example, when analyzing the motion of a cricket ball, the effect of the Earth is smaller. The first postulate is even though If a ball is moving on the earth, its centripetal acceleration is greater than the gravity. The gravity is also neglected with zero, but we have not. If we want to analyze the motion of the meteor falling from the great distance toward Earth rotates must be considered. An observer at zero moving with the box car, the midway between A and B, and the ground observer at O, the midway between A and B. The events recorded by the observer light signals are the lightning bolt. Two light signals reach to observer at zero at the same time. The observer realizes that the light signals have traveled at the same speed over equal distance. Observer 0 conductor even A and B caught simultaneously. Now consider the same events as viewed by the observer on the box car at O. By the time the light has reached observer O has moved. Thus the light signal from B has already swept past O, but the light from A have not yet reached zero. Accordingly to Einstein, observer O must find that light traveled to the same speeds as that measured by observer zero. Therefore, observer zero condenses the light